Okay. Give me the equation again.
It was how do we find the zero of the function? And then the other part was, does f have a zero? If it does, find the zero. And then it's f of x equals negative 1/2 x plus 2.
Okay. When you're looking for a zero, it's a place where the function crosses the x-axis. So what
Okay.
we're going to do is, oh, you're not on Scribbler. I need you to actually click on the link for Scribbler. Do I need to send it to you again?
The same link? I can find it.
Yeah, it's the same link.
Okay. This is a lot better than Starbucks.
You think?
Yeah,
I could barely hear you there.
I know. It's very loud there. Oh, sign in as a guest. What was that again?
There you are.
Okay.
Do I have the equation written correctly?
Yes.
Okay. So I'm just going to graph this line really quickly. Okay. Do you understand how that's the picture of the line?
Yes.
Okay. So I'm going to put a big red dot where the zero is. Oh, that didn't turn out red. Hold on. So a zero happens where the function actually crosses the x-axis.
Mm-hmm.
Huh. Maybe I didn't graph that right. Down 1 over 2. Down 1 over 2. Okay. So in order to figure out where this is going to be, I'm going to make this 0.
Okay.
And so the equation I get is 0 is equal to negative 1 over 2x plus 2.
Mm-hmm.
And now I'm just going to solve for x. So
Okay.
so if I'm trying to look for a 0 for x, I make y equal 0.
Okay.
So solve that mathematically for me. What's x going to be equal to?
I think what we got was x equals 4. That's what
Mm-hmm.
we got in class. And I
So
did it myself. I got the same thing. Yeah.
okay, and if you see that graphically, you see where it crosses the x-axis, where that red dot is. It's at 4.
40. Mm-hmm.
So when you're looking for the zeros for a function, it doesn't matter how complicated the function is. You set the function equal to 0 and solve for x. That's how you find them.
Okay. So the zero of the function would be 4.
The 0 of the function would be 4. Yes.
Okay. And it says, does f have a zero? If it does, find the zero.
Well, does f have a 0?
We put set f of x equals 0. That's what we just did.
Right.
So is there a chance that it might not have a zero?
This is the only way that it's not going to have a 0, is if the line is horizontal. And what I actually haven't done that with you. Okay. So
Mm-hmm.
when when you have a line that goes straight across and is horizontal, what kind of equation is that? Do you know?
From what we said here, it doesn't have a slope. When the line isn't that uh is that the h plus k? It's
Okay, I'm gonna try to make this as easy for you as possible. Okay, so I'm gonna clear this. This is the what I call the line man.
mm-hmm.
So here are his eyes. That's his nose, and that's his mouth. And all the lines that I draw represent the slopes for the line of a represent the slopes for a line. So if the line is pointed that direction, it's got a negative slope. So it's pointed to where there's negative I.
Mm-hmm.
If the line is pointed that direction, then it has a positive slope.
Okay.
If the line is straight up and down, then you see where his nose is? His nose has a U shape, right? So that U stands for undefined. And it means that X is equal to some number. If the line is straight across, then the slope is 0. That's why the corners of his mouths are zeros. And the equation for the line is y equals something.
Mm-hmm.
So when I draw this picture, and I draw a line, so that's my line.
Mm-hmm.
Which line is the same as the line on the line man's face?
Where the y is at?
Where the y is. So I'm going to literally write the equation for the line as y equals, and then what is the y equal to at that point?
Well, I think you said 0, right?
No, the slope is equal to 0, but what is the y equal to?
Oh, 4.
4. So that's the equation for the line.
Oh, that's it.
That's it.
Because there's no slope.
There is a slope. The slope is 0. So the slope is equal to 0, but the equation for the line is y equals 4. If you look at the equation for a line, it's y is equal to mx plus b, right?
Mm-hmm.
What does the m represent?
The slope,
And what does the b represent?
the y-intercept.
Okay, so let's look at that line that I just drew. If you look at the line man, the slope is equal to 0. So that means that y is equal to 0x. And then where does a line cross the y-axis?
At 4, plus 4.
Anything
Mm-hmm.
times 0 is what?
0.
0. So that's why the equation for the line is y is equal to 4.
Okay.
Okay? Now let's look at it at another line. I'll draw it in another color. Hold on.
So when they're asking, does f have a 0? They're just saying if you set it to 0, are you gonna have like
Do you get a value for x? That's what they're asking.
do you get a value for x?
Mm-hmm.
Okay.
So for this one, do I get a value for x for that first line? The black one.
You
that I just
don't.
did.
You
Huh?
don't.
You
You
don't.
don't. Mm-mm.
So that one doesn't have a 0. What about the blue line?
The blue line, you do.
And what would the value be?
Um, I just went ahead and said you do. I don't know.
Well, I'm trying
I'm
to make
sure
the
it
little
has a
tick marks.
slope.
These are the tick marks right here. So what is
Okay.
the x value there?
It looks like it's 3.
It's 3.
Hmm.
So that's x is equal to 3. That's the actual 0 for it.
Okay.
So all that being said, when they ask you for the zeros for a line, they're asking you for the x values.
Okay. By making y 0, you find what x is, and they're
Right,
asking
right.
value. Okay.
So if I have, just to double check, let me clear all this. If I have an equation and I ask you for the zeros for that line, what would the 0 be equal to? And how would I find it?
If you have this equation, maybe do you want to get y on one side first?
You want to get y by itself first. That's the first thing you want to do. Yep.
Okay.
So I want you to
So
actually do that math because I haven't seen you do any math yet.
okay. Let me see here. Let me get a pencil and change the color. You said okay. You said it was easier to use your mouse, right? Okay.
Yep.
Okay. Okay. I'll fix it. I'm just trying
Yep,
to
that's fine.
2x minus a. Divided by 4. Oh, it's gonna be this whole thing divided by 4,
Uh-huh.
and then minus 8. I want to simplify it. So is it gonna be like 1/2? I mean, these things. That's where I get confused. Like sometimes I don't know how. I mean,
Okay,
I've done it before, but it's been a while.
so this 4 goes into that number and that number. So you are. It's going to be 1/2 x minus 2 equals y.
1/2 x minus 2 equals y. Okay. We want. We're trying to find x, right?
Yep.
So plus 2. This whole thing times 2. 4 plus 2y. That's what I got.
Okay. If we're trying to find the 0, what are we supposed to do to the y?
Um, we need to make y 0.
You need to make y 0. So what would x be equal to then?
So if I make y 0, that means this would be 0 here. X would be equal to 4.
Right. Now let me make this easier for you. Okay?
Mhm.
Did you see all that work you did?
Yes.
Let me show it to you a different way that might make it easier. So I'm going to start off with the original equation again. Let me delete
Okay.
this.
This one.
So I have, oh, all right. So I have 2x minus 4y equals 8, right?
Okay.
I'm going to
Yeah.
start off by making this y 0 because I'm looking for the 0 for the function.
Okay.
So if I stick in 0 there, what happens to this 4y term?
It's gone.
It's gone. So now I'm
So
left with 2x
2x,
is equal to 8. And so what is x equal to?
4.
Is that a lot easier?
It sure is. Yeah. So you don't have to have y by itself.
You don't have to have y by itself. You just set the y equal to 0. Or you would set f of x equal to 0 and then just solve. So you get rid of that term because it goes away. That's what the 0 actually means. So if I give it to you like it is in pre-calculus, because they write everything in terms of f of x, and then this is and I ask if that f of x has a 0, then what happens to this term?
Well, you're setting it to 0,
Right?
and so then you solve.
Right?
So plus 25 on that side will equal 5x. So divided by 5, 25 divided by 5 is 5. So x will equal 5.
And now, so does that f of x, does that f of x have a 0?
It sure does,
It sure
yes.
does.
And you said the only reason it wouldn't have a 0
Is if you
is
had
if,
this.
okay,
Does that have an x?
it doesn't.
It
No.
doesn't. So does it have a 0?
No.
Nope.
Okay, that makes sense. And you know the other thing that they're saying is that the range would be B. Is that correct?
What was that?
If m equals 0, the range is B.
If m is equal to 0, then the range is what?
Let me write it. Let's see here. They're saying the range,
Okay. What's another way of saying range?
the y-intercept, or
It's just
where
saying
y is, where
it's
it's
just
touching
saying y.
y.
Range is y.
They're
Domain
saying
is
B.
x and range is y.
Yeah, this is what he said in the notes. Is that correct or is that wrong? Was that supposed to be 0?
Does it say 6 comma 6?
No, B comma B.
And so that the range is b?
Mm-hmm.
Yes.
B. This is correct?
Yes. If I'm understanding you right.
Yeah, because this is what he wrote in the notes. He said if m equals 0, the
If
slope, the
m
range is B.
Okay. Okay. All right. So this is what it's saying. That's your original equation, right?
Mm-hmm.
I'm going to stick in 0 for m.
Mm-hmm.
So I get f of x is equal to b.
Right.
So the range is just going to be from b to b. Do you understand interval notation, what that actually means?
That's what I have a question on. Because I mean, I understand like why the y is B, but I don't understand why the x would be B as well.
Well, there's no x in this range.
Mm-hmm.
When you are doing domain and range, all of the x values are the domain, and all of the y values are the range.
Okay.
So what is the only y value for this function?
B.
B. So it goes
Mm-hmm.
from b to b. So that means it's constant. That's what the range means. When you're dealing with range, you're only looking at the y values. Let me give it to you this way. Okay, so let's say I have these points. Let's say I have those 3 points. And those 3 points represent some function f of x. Okay?
Right.
If I want to write the domain for this, the domain would be -1, 2, 3. That's the domain. Because that's an x value, that's an x value, and that's an x value. And when you write the domain, you write them from least to greatest. The range is the range would be 3, 4, 5.
Mm-hmm.
Because this is a y value, that's a y value, and that's a y value.
So it's just the values.
It's just the values.
Okay.
These are all the x's, these are all the y's. That's the difference between domain and range.
Okay.
So if I have some f of x and it's equal to 2,
Mm-hmm.
what would be the only value for the range for that function?
If what would be the only value for the range? 2.
2.
That's it.
2. That would
Mm-hmm.
be it.
So 2, 2, 2, 2.
So 2, 2, or you could just write it as 2.
2.
You could just write it that way because it's the only element in it.
Yeah, that's what I would think you would write it. That's why I was like, why is it BB? That was just weird to me, but okay. I mean, hey, to each his own.
Do you know what the brackets mean, by the way?
Included.
Right. So it means equal to.
Equal. Okay, equal to. Okay.
And then if I have a parentheses, do you know what that means?
That is not included.
That it's not included, but it starts there.
Okay.
So it means less than. Without the equal to sign.
Okay. That makes sense.
So remember, whenever they say domain, you're talking about the possible values for x. And then when they talk about range, they're talking about the possible values for y.
Okay. And then it's talking about, what's it called? The next section is talking about quadratic functions and their zeros.
Okay. Do you know what a quadratic function looks like?
I memorized the formula. We did it so much in
okay,
chemistry
so
too.
I'm gonna draw a couple of quadratic functions for you, okay? Just so you can get an idea of what they're talking about.
Okay.
Okay, I'm gonna put the first one in green. Actually, I'm gonna make it. Okay, so that's a quadratic function.
Okay.
Where would the zeros be for that function, knowing what we've just talked about? Where are they located?
For the x?
It's where that green line crosses the x-axis. So put a dot on the 2 places where it crosses the x-axis.
Okay. Right here? And right here.
And what would those values for x be?
2 and -1.
That's correct. So those would be the zeros. It would be at 2 and -1. So if I wanted to write this quadratic equation, and I'll write it this way, f of x is equal to x plus 1 and x minus 2.
Mm-hmm.
That's the actual equation for it. Now, there might be some function of a that's a compression or a stretch, and we would actually have to solve that.
You have x minus 2. Is it not plus 2?
Well, okay, remember we said that these were zeros, right? So what I'm going to do
Yes.
is I'm going to take each one of these parentheses and I'm going to set it equal to 0. So you get x plus 1 equals 0, and you get
Okay.
x minus 2 equals 0. So if I solve the first equation for x, what number do I get for x?
-1.
Do you see why it's flip-flopped? Why I did that now?
Yeah, I do.
What would the other one be?
That would be positive 2.
So when you're writing it in the equation, the sign always changes from what the actual 0 is. And I'm guessing in your pre-calculus class, if you haven't done this yet, they're going to say, okay, the zeros of this function are -3 and 5. Write the formula for a possible equation for the function. Have you done anything like that yet?
Is that what completing the square is? Is that what that is?
Nah, that's completing the square actually tells you where these things are when you're actually trying to rewrite the function, and we can go over that too. This is when they
Yes.
start with the zeros. So if I wanted to write the function using those 2 points, I'm going
Mm-hmm.
to do exactly the same thing that I did here. I'm going to say that f of x is equal to x plus 3 times x minus 5. And then I'm going to
Okay.
FOIL it. Can you FOIL that for me?
I sure can. Okay. Let's see here. It's so bad. I'm not used to using a mouse. Okay.
You
3.
can make your pen a little bit less dark so it kind of writes a little bit smoother. You see where you selected the pen and there's like a little line saying how thick or light it is? You can just
I
thin it
found
out.
it.
Okay, you figured it out.
Okay, and then you want to make it easier. So -2x minus 15 x squared.
And then that's equal to f of x.
Hmm. That's cool. So, because you want to do the opposite sign, because you know if you put it to 0, it's going to give you what the x is, right? Because
Right,
you
right,
said the
right.
quadratic is when it crosses the x-axis.
Uh-huh. Now
That
let's look at another piece since we talked about domain and range. Okay. So for this function, your domain, because these arrows, the green arrows that I have here, go on
Mhm.
forever, your domain would be equal to all real numbers. So if I want to write that in interval notation, it would be -infinity to +infinity.
Included. Yeah.
No, when you do infinity, it's always parentheses. Because
Really?
you don't know
Okay.
what infinity is, do you? Do you know what number infinity is?
No.
That's why it's always parentheses whenever you do that.
Okay.
It's never brackets. Okay,
Cool.
so that's looking at the function this direction, to the left and to the right. That's domain. So if I want to look at the function up and down, then that would be range.
It will be -4 to infinity.
Right. That's perfect. Now, are you going to put brackets or parentheses around it? How are you going to label it?
Well, -4 is included,
Right.
and then infinity, we don't know what it is, so
Perfect.
it's gonna. Okay. Cool.
I love teaching adults. I swear to God, I love
Why?
teaching adults.
How
Because
so?
adults are so invested, they just want to get the information, and then when a light bulb goes off, they're like, "Oh, I get it," and they get excited about it. It makes me happy.
That's good. What do kids do? Or
Well, it depends on the child.
they don't care. They're just like, oh, you know.
Yeah. Sometimes they seem not impressed at all. Sometimes they do, but sometimes they just seem like, okay, I get it. I'm just like, come
That's
on, we've
funny.
been doing this for like 20 minutes, and you finally are getting the right answers. You're not more excited about it?
I'm excited. I know I'm excited. I'm paying for my credit. It's not free in high school.
There you go. That's right.
College is not free.
College is not free.
Oh, the next thing they're asking is completing the square.
Okay.
It has ax squared plus bx plus c equals 0. Maybe I should write what they have here. Let's see. Oh, this is okay. Good luck with this one. Okay. This one. Ax squared plus. I'm gonna be an expert at this soon. Okay. Plus c equals 0 and an arrow, and then he had x plus a, and it's 1, and then he has this 2 equals c1. And then he said, find the zeros of the function. Isn't that what we just did?
That is what we just did.
Okay. Is this just like a formula for completing the square or something? Or
Okay. So he said find the zeros for the function, or did he say complete the square?
it says completing the square because this is well, it has finding zeros of a quadratic function, and then
Okay.
it has,
Can you go to the section in the book where they're actually giving you questions for completing square? Is that like in the notes parts of the book?
yeah. What I'm giving you is in the notes. So you want an actual question?
Yeah, I want an actual question so I can actually take it out of the math speak, because they're doing all this stuff in general terms, and I don't think you're going to get it. But
Okay.
if we do an actual question, then I can show you what they're trying to say here.
Okay. Let me see what he assigned in the paper. I don't think I got to that. I didn't understand his class at all. Okay. Let's see here. 2, 4. 2.3.
What I'm going to do is I'm going to leave this in general. So once we actually have it, and if you can't find a question, I can give you one because I have software that generates stuff that we can use. But I want to keep that up there at the top so I can show you what they mean by that.
Number 17, let me find how is using 17 through 29. Find the zeros of each one and completing the square. Okay, I guess that's what he wants us to do. He said to 29, okay. Uh, he didn't assign that as homework for some reason. Let me see if we 41. It says, find out the rows of infinity and eventually either project. Okay. Who will contain speech? Does he not want us to learn that? Because he didn't assign it as homework. It was like, what he assigned as homework was number, the odd 17 to 29, and that includes find the zeros of each quadratic function by factoring one of the x-intercepts of the graph of the function. And then another one is find the zeros of each quadratic function using square root method, one of the x-intercepts of the graph of the function. And then he moved on to 41. It says find the real zeros, if any, of each quadratic function using the quadratic formula. What are the x-intercepts, if any, of the graph of the function? And then
Okay.
57 is find the real zeros of each function. What are the x-intercepts of the graph of the function?
I wish you would screenshot your book for me. Actually, you can. Can't you take a picture of that and send it to me on the phone?
I can, yeah.
Yep.
You can choose the hardest one.
Let's do an easy one first so you can see actually how it works.
Okay.
And then we'll do a harder one with the quadratic function or the quadratic formula. Here's the other thing that I want you to keep in mind, just while you're sending that to me. Let's say that my quadratic looks like this. Does that quadratic have any zeros?
It's not touching the intercept. I mean, why?
Go with
I
your
don't think
gut.
so.
It's
No.
not touching the x-axis, right? So does it have any zeros?
I don't think so.
No, it doesn't. And so when you use the quadratic formula, you're going to get imaginary numbers when you actually find the zeros for it. The zeros are going to be imaginary. So I want you to keep that in mind when we actually do one that's more complicated.
Okay. So quadratic formula never touches the y-axis or the x-axis?
When you use the quadratic formula, if you get an imaginary number or a negative under the determinant or the discriminant, then that means that it doesn't touch the x-axis. Sometimes you can use a quadratic formula and you'll get a square root of something, and that just means that it doesn't touch exactly, one of the tick marks. But when you get an imaginary, and they always run in pairs, conjugal pairs, then that means that particular graph never touches the x-axis. That's what I'm trying to tell you.
Gotcha.
All right. Okay, I got it. Okay, I'm looking for the one that's talking about complete the square.
These were the three texts I just sent you. That's what you assigned on the homework. And it's interesting. The one for completing the square was not what was assigned on the homework for section 2.3. So I was wondering, did he not want us to know that?
It's hard. I would rather teach it to you so you would know how to do it than not teach it to you. So let me. Okay, I'm gonna do question number 41.
Okay.
And I'm going to do it doing completing the square so you can see why this thing is important, what this actually means. So I think it's important for you to know that.
Okay.
Because if you ever take calc, I don't know if you have to or not, you're going to need to know how to complete the square.
Yeah, I'm gonna have to take it. Yeah.
I'm going to do an easy one first, so I'm actually going to do 39 first. And then I'll do 41, so you have two examples of it. So I'm going to do an easier one and then a hard one. So I have f of x is equal to x squared plus 4x plus 1. Okay, so the value there, that's my a. This value there is my b. And that value there is my c. Do you see how those numbers match up with this general equation up here?
Mhm. Are you doing an even one? Even?
I'm doing
Versus-
39. I'm doing an odd one first. And then I'll do
Okay.
42 next. Because 42 is a little bit harder, but I want to show you the process on something that's easy first.
Okay. 38 is even. The one that you're doing. That I didn't know if you wanted to do 39 or 38.
I'm sorry. I did write that backwards, didn't I? Hold on. I'm trying to do number 39. What I see for number 39 is this is negative. Hold on, let me fix that. And this one is negative. Oh, I really messed that up. Sorry. Do we both have the same question now?
Yes.
Okay. So this 0 here is telling me to make this thing 0.
Okay.
So that's what I'm going to do. I'm going to set this whole thing equal to 0 because that's my first step. And now, you see how I have this c term here? That c term is going to change, and that's why they labeled it C1. So let me show you how to do that. So the first thing that I'm going to do is I'm going to move this 1 over to the other side. So I get x squared minus 4x plus some number is equal to 1. Do you see how I just moved that 1 over to the other side?
Yes, I did. I saw that.
Okay, so now I'm
But
going to
C,
focus.
that's what C is telling us to do.
Yeah, that's what C is telling you to do. Because eventually I'm just going to get one parentheses over here, and it's going to be x and some number a, which we're going to figure it out. So let me show you how to get that number. That middle term there, I take that number, I divide it by 2, and then I square it. So I can complete the square. That's how you complete the square.
Okay.
So,
Divide it by 2 and then square it. That's how you complete the square. Okay.
so what's negative 4 divided by 2 and then squared?
Negative 2 and squared will be 4.
So if I add 4 to this side, that's why I left that blank. I need to add 4 to this side too. Because I haven't changed anything. If you add the same number to both sides, then you haven't changed the equation.
Okay.
So when I add those two things together, I get 5 here. And then this is now a perfect square. So if I take x minus, because the sign stays the same, and then I take the square root of the last term, that's 2, and I square it, then now I have the exact same setup as up here.
Oh, wow.
So that means that C1 is equal to 5, and A1 is equal to negative 2.
Okay.
And that's what they're basically trying to tell you. When you complete the square, you get a perfect square on this side, and that's equal to some number.
Okay. How do you know that you need to complete the square? Will they tell you? Or is it because of the negatives or
When you are completing the square, you are getting that equation in vertex form. So what that means is I can now graph that. I know what my h and my k are.
Mhm.
So that means that the vertex would be at negative, the vertex would be at 2, comma 5. And when I draw that, if I go over 2 and then I go up 5, then that means that my vertex is there.
Okay.
Oh, hold on.
How do you find vertex? Is that just based off the slope, right?
It's not. There's not a slope for quadratic. For the vertex is either the bottom or the top of the function. So if I do negative b plus or minus 2a, so let me look at this. Let's say negative. So my quadratic is going to look like, sorry, I put that point in the wrong spot. Let me go back. Normally when you have the equation in vertex form, it looks like this. F of
Mhm.
x is equal to h minus k, or x minus h plus k. This number represents the x coordinate, and this number represents the y, so your vertex is at h, comma, k. Does that look
Okay.
familiar?
Yeah.
So if I reordered this equation, my f of x would be equal to x minus 2 minus 5. So I'm going to bring this over to that side, back over to that side. So that means that my vertex then would be at 2, comma, negative 5. So if I'm graphing this thing, there's my vertex, and then my quadratic opens that way. So your vertex is always the bottom of your curve. It's either the maximum or minimum of your quadratic. That's how you know how to graph it. Are you with me?
Does that work with everything else? The other functions?
Each function will have a vertex, yes.
Okay.
The general equation for them will be slightly different, but each of them will have a vertex. You can put all of them in the h comma k form, and because we're dealing with a quadratic, that's why we're completing the square. That's how you get it in the vertex form, so you can actually start graphing it.
Okay. Sounds good.
I don't want to put too much on you, so let's just make sure you understand how to complete the square first. But
Okay.
The reason that you're learning to complete the square is so you can find the vertex. That's the whole reason behind it. There's also a lot easier way of finding the vertex than completing the square, and I can show you that shortcut here in a second. But I want to do another one for you so you have one to study with. So let me close this. I'm going to write this back up. ax squared plus bx plus c, and that's equal to 0. And then that means that you can complete the square, and this is x plus a1. I don't know why they did that, because that just makes it more confusing. Making a plus instead of minus is equal to
Okay.
c1.
It's usually minus.
Well, if you're writing a vertex, then the stuff inside the vertex, you always have to switch the sign in order to figure out what the actual 0 is. Remember we just did that?
Yeah, I remember that. Yeah. So
So
that's
that
how you find vertexes when you make y 0.
right when you make y 0.
So you can do that for any function.
You can do that for quadratic functions. Let's just stick to that.
Okay.
Okay, so I'm going to do 42 now because it's a slightly different process. So we have g of x is equal to 2x squared plus 5x plus 3. And I want to complete the square doing this. So the first thing that I'm going to do is I'm going to set it equal to 0. And then in the next step, I'm going to move the 3 to the other side. Okay? Now that I have a number in front of the x because I have an a term, I have to divide that out. So I need to factor that out. So it's going to look like this. There's going to be a 2 there. This is now going to be x squared. This is going to be 5 over 2 times x. And I have some kind of blank there in order to complete the square. And that's equal to negative 3. Do you understand how I factored the 2 out?
Because you said that since there was a 2 in front of the x, you have to bring it out.
You have to bring it out.
Okay.
Do you
And
get
so
how I got this fraction here when I factored it out?
um, you told me something about dividing it. You just do that?
Yeah,
Is
you
that
divide everything by 2. Because if I divide each one of these terms by 2, don't I get what I have written there?
Isn't that what we did before? You said to divide that term by 2 and then square it?
We haven't done that part yet. We haven't done that part yet. I just factored the 2 out. And I want to make sure you understand how to factor something out.
Okay. So why did we divide it by 2, 5?
Okay, do you see how this x squared term is by itself now? There's no 2 in front of it?
Yes.
How would I change from 2x squared to just x squared? What would I have to do to that term?
Multiply it by 2.
Think of it the other way, because I'm starting with this one, and I want to get to that one. So how would I get to the bottom one?
Divide by
You
2.
divide by 2. So I had to divide that term by 2. That's why I have the 2 on the outside. And in order to do that, then I have to divide this 5 by 2 also. That's called factoring.
Okay.
So I factored out a 2. That's what it looks like.
Gotcha. So you're dividing by 2 to kind of get it by itself.
Right.
Okay.
Okay, the next step is the step that I told you about. I have to take that second term, which is 5 over 2. I've got to divide it by 2. That's just like multiplying it by 1/2. And then I have to square the whole thing. So that is 5 over 4 squared.
Okay.
What's 5 over 4 squared?
Well, do you square the top, you square the bottom?
Yes.
5 times 5, 25. 4 times 4, 16.
So that number goes in there. So this is 25 over 16. So now I have to take the 25 over 16 and multiply it by 2 because I have this 2 out front. So this is going to change to 25 over 8. Do you see how I got that before I move on? I want to make sure you get the math because most people freak out when they see fractions.
I don't know how you got that. 25 times 2. Did you just do 2 over 1 and why?
I did 2 over 1 and I just reduced.
Okay.
That 2 changes to a 1, right? What does the 16 change to?
Oh, okay. I don't know how you got that.
Okay. Okay.
It's been a while.
That's all right.
Because I would just think 25 times 2, okay, you multiply that, then you would kind of reduce it after you get your answer.
This is called cross canceling.
Okay.
Is this number a top number or a bottom number?
Bottom number.
Is this number a top number or a bottom number?
Top number.
When you have a top and a bottom, you can cross cancel, which means you can divide both numbers by the same number to make them smaller. What
Okay.
number do 2 and 16 have in common?
2.
So when you divide the top 2 by 2, what number do you get?
1.
So that number changes to a 1. When I take the 16 and divide it by 2, what do I get?
It should be 8. Yeah.
And so that's why I got this number. That's
Okay.
how I got it.
I've never learned that before.
Most teachers do a horrible job of teaching fractions, and that's why they have such a bad stigma to them. But if you can add, subtract, multiply, and divide, you should be able to do the exact same thing with fractions because all the same rules apply. You just have to know the rules.
Yeah. That's because, what they've always taught us is, okay, 25 times 2, 16 times 1. Okay, then reduce from there. Yeah.
I always try to reduce first because the numbers get smaller, so the math is easier for me.
Yeah, that's good. I like that idea. I learned something. You learn something new every day. But can you do that with 25 and 1 too? If they were different numbers, if they're top.
You can only cross cancel when the numbers have a number in common. If they don't, then you just multiply them.
Okay.
Because if you have like 25 and 1, they don't have anything in common, so they just stay the same way, right?
Right.
Okay, so I'm going to try to erase.
But if they did, I could do top and bottom with like the numbers that replace 25 and 1, and I can do the same thing with 16 and 2 as well, right?
Right. It doesn't matter what side they're on, as long as it's a top number and a bottom number, you can reduce it. It doesn't matter where they are. So if you have something that looks like this, it would be really, really hard in your head to multiply the top, multiply the bottom, and then reduce, right?
Mm-hmm.
So instead of doing that, I'm going to cancel. I'm going to cross cancel. So I know that 18 and 36 have what number in common?
Um, 18 and 36. I want to say 6.
Bigger.
Is a big one 9?
Bigger than 9.
Ooh, would it be 12? No, it can't be 12.
What is that number?
It's not 9?
It's okay. Let's start with 9. Let's start with 9. We can start there. We'll just have to do it twice. So how many times does 9 go into 18?
2 times.
So that changes to a 2. How many times does 9 go into 36?
4 times.
Okay, let's reduce again. How many times does 2 go into 4?
2 goes into 4 2 times.
So that changes to a 2. How many times does 2 go into 2?
1 time.
So I could have divided by 18 and gone straight there.
Oh, 18? Okay. Okay. I didn't know 18 was... I'm not familiar with that one.
That's okay. Okay, what's the biggest number that 12 and 40 have in common?
Oh, I believe 12.
No, not quite. Not quite 12.
Really? Let's see here. Would it be 6?
A little bit smaller.
5?
A little bit smaller.
Oh, 4 then.
4. How many times does 4 go into 12?
3 times.
How many times does 4 go into 40?
10 times.
Okay, so now let's look at the fractions that I have. So I have 3 over 1 times 2 over 10. Can I reduce up and down this way? Do I have a top and a bottom number there?
You do.
Okay. What's the number they have in common?
5. Well, 2.
2. What does the top number change to?
1.
What does the bottom number change to?
5.
Now I'm going to multiply. What's 3 times 1?
3.
What's 1 times 5?
5.
And that's the
So
number I'm going to
3.
use.
Okay. That makes sense.
So you can reduce along the diagonal, or you can reduce straight up and down.
That's good. That's good. I learned something new. I did it the hard way.
Okay. Let's go back to completing the square now, because I have this stuff all over the place now.
Okay.
Again, you can go back and review all the stuff that I have here. I will post this stuff up before I go to bed tonight. I'm not sure when it will publish. It might take 30 or 40 minutes for it to publish, but I will make sure that I send it up tonight before I go to sleep.
Okay. Sounds good.
Get rid of this. And I'm going to get rid of this. Okay, so the number that I got by the time I was done reducing was 25 over 8, right?
Okay.
And that came from these two numbers being multiplied by one another. So that's the number that I actually have to stick over here, so I make sure that I have the same amount on both sides.
Okay.
All right. So let me get rid of this. So now I have a perfect square in here. This is going to be 2. That number 2 still stays there. And this is x. The sign there is positive, so this is going to be plus. And then I take the square root of this number, and so that's 5 over 4 squared. And then that's going to be equal to, let me show you a nice little trick for this. Because your teacher probably didn't teach you this. If I want to combine this all as one fraction, I take this number and I multiply it up to that number.
24, negative 24, plus 25.
And then I use the exact same denominator for both.
Mm-hmm.
So what's 24 minus 25? Or negative 24?
1 over 8.
So this would be 1/8. So this is your C value, and that is your A1 value. If I wanted to know my HK, then this would be negative 5 over 4 and comma 1/8. That's where my vertex would be.
Yeah, because if you set it to 0, it's opposite, right?
It's opposite.
The vertex.
And it doesn't get any harder than that when you're completing the square. That showed you all the steps that you have to take in order to complete the square.
Wow. Not bad. So when they're asking, like this says find the real zeros of any of each quadratic function using the quadratic formula, what are the x-intercepts if any? Just the same question, but they're asking.
Okay. Let me do the exact same question. Let me erase this because that was completing the square.
And so that I'm going to use that in calculus.
Yes, you're going to use completing the square in calculus. Okay, so I want to find the zeros for this. Remember, the zeros and so let me just draw you a picture. So that was at -1/8, negative. So like the vertex was like there. My zeros are going to look like, and I'll put them in red dots. So do you see how the zeros are different from the vertex?
The zeros are different from the vertex. Yeah.
Because my vertex, let's say, is this big blue dot right there. And the zeros are the red dots. So those two things are two different sets of points. Do you get that part?
Yes.
So when I use a quadratic equation, I'm actually finding the red dots. So let's use the quadratic equation to find the red dots. I'll even write the stuff up in red. So the quadratic equation says that -b plus or minus the square root of b squared minus 4ac all over 2a, that's equal to x.
Okay.
This is your a, this is your b, and that's your c.
Right.
So I'm just going to plug it straight into the formula. So I get -5 plus or minus the square root of 25 minus 4 times 2 times 3 all over 2 times 2. Do you see where I stuck the numbers? Does it make sense where I stuck the numbers?
Yes.
Okay, so 8 times 3 is what?
8 times 3 is 24.
25 minus 24 is what?
1.
So I get -5 plus or minus the square root of 1 all over 4. Do you see where I got that part?
Mm-hmm.
What's the square root of 1?
1.
So I get -5 plus or minus 1 all over 4.
Okay.
Okay, so I can separate these into two different numbers. So 1x is equal to -5 plus 1 over 4. And then the other x is -5 minus 1 over 4. Do you see how I separated the two?
-5 plus 1 over 4. -5 minus 1 over 4.
This is where that plus and minus term comes in. I'm just separating those two. I'm making one of them plus, and then I'm making the other 0 minus. Because it's plus or minus 1. You see my plus 1 there?
Yeah.
And you see my minus 1 there?
Oh, yeah, yeah. You just got to try both of them.
You just got to try both of them. So
Okay.
do the math for me. What's -5 plus 1?
It should be -4.
-4 divided by 4 is?
-1.
So that's one of my zeros. And then I'm going to do -5 minus 1
-6.
over 4.
Let's do some
Just reduce this.
simplifying.
-6 over 4. Just reduce
3
it to
over
a fraction.
2. -3 2.
-3 over 2.
Mm-hmm.
So those are your two zeros. That's how you would do that.
So it's just saying. So we're finding the x, and I think you had told me before. If you're finding the x, that's your zeros. That's
Right.
what you had told me.
Right. And the quadratic formula allows you to find your x's just right away by just sticking it into the formula. It already has it solved for x. So another way of writing this would be to write this as g of x equals x plus 1 times x plus 3 halves. That's the factored form. And I'll prove that to you. And I'm going to show you a way of sliding and dividing to get these two factors. Do you have those two factors written down? Because I'm going to erase some of this stuff.
Yes, I got it.
Okay. All right. So this technique is called sliding and dividing. The first thing I'm going to do is I'm going to take these two numbers and I'm going to multiply them together. What do you get?
6.
I need a factor of 6.
Oh, so is this factoring? How to factor?
Yes, this is how to factor that. I need a factor of 6 that multiplies together to give me 6 and adds together to give me 5 because it's that number. So what factors of 6 actually do that?
Okay. So we started out with, you said 2 times 3, and you asked what that was. That was 6, and you said what together?
What multiplies together to give you 6, and then the same two numbers add together to give you 5.
2 and 3.
So my next step is I'm just going to put those numbers next to x. So this is x plus 2, and this is x plus 3. The next step that I have to do is I have to take this number and divide both numbers by it. Okay? Now, when I factor this, I get x plus 1, and I get x plus 3 halves.
And the only reason you did that was because it had that 2 there for the x, right?
Right.
Yeah, we did that before, I remember. Cool. So that's how you factor.
That's how you factor. So if you can factor something, you don't necessarily need the quadratic equation, but we still got the same two numbers. We got -1 and -3 halves. And those are the numbers that I got from the quadratic equation, right?
Right.
So you could do it either way.
That's cool. What about when it's talking about the square root method? Is that different?
The square root method is kind of the exact same thing, except for I'm going to take the square root of the function from both sides. Let me look. Let me look at so I can get an example. What set of questions are those that talked about the square root method?
Those are 25 to 30. He wanted us to do the odd on that one.
Okay, so I'll give you an example. You already have it in vertex form, so I'll do 25 and then 28.
Okay.
So the first thing that I do is I set this equal to 0. So I get x squared is equal to 8. Do you see how I got that?
Yes.
And then I'm just going to take the square root of both sides. Whenever you take the square root, you have to write plus or minus in front of the square root. The square root of x squared is just x. And then this would be plus or minus 2 root 2. Do you see how I got that? Or do I have to teach you how to do square roots?
I think a good review would be nice. And I have one question going back to the vertex. You know how we wrote it in that form like -1, comma, -3/2, right?
Uh-huh. Mm-hmm.
That's not an actual point, is it? Because they're both
No.
x's.
It's not an actual point. The actual point would be
-1, 0.
-1, 0. That's the
Okay,
actual point.
gotcha.
I'm listing the actual intervals there where they're actually where the zeros actually are. It's like set notation. So
Okay,
you could say like the x values such that x is equal to -1 and x is equal to -3 halves. Because I'm just talking about the x values for those two different points. That's all. That's not
okay,
giving you, because the y values are 0. We already said the y values were 0, right? We said that there.
yeah, okay, gotcha.
So if they ask it as an ordered pair, then you're going to answer it this way. If they just want to know the zeros, then you're going to answer it this way.
Okay.
Okay. Let me go back and do some radicals. Okay. I'm gonna do the radicals the easiest way that I know. So this is what I want you to do. Tell me what 1 squared is.
1 squared is 1.
What's 2 squared?
2 squared is 4.
What's 3 squared?
3 squared is 9.
What's the next one squared? I want you to just go in order until you can't do it anymore. There's a method to my madness.
4 squared, okay. 4 squared is 16.
Next one.
5 squared is 25.
Next one.
6 squared is 36.
Mm-hmm.
7 squared is 49.
Mm-hmm.
8 squared is it 48? 8 times 8,
8 squared is 64.
64. 9 squared, whoo, man, is that 21 or something? 81.
It's 81.
Yeah. 10 squared is 100.
Mm-hmm. Can you go higher?
11 squared, that's 121.
12.
12 squared is, is it 120?
It's 144.
44.
That's good enough for now. Okay. So which one of these numbers divides evenly into that one?
Well, definitely 4.
Okay, so if I have 8, then it factors into 4 times what number?
2.
Now, because I have a square root here,
Mm-hmm.
I'm going to put a square root on both of those numbers.
Mm-hmm.
What is the square root of 4?
2.
So that's where this 2 comes from.
Oh.
Can you take the square root of 2? Can you simplify that anymore?
No.
No, that's why this stays exactly the same.
Oh, man. This is high school.
Yeah.
Okay. Yeah. Okay. That makes sense.
So whenever you have a number that you have to take the square root of and they want you to simplify it, think in terms of these numbers, figure out the biggest one of those numbers that you can divide into it and then separate it and then do it that way. Because sometimes you'll be left with a piece that you can't do anything with. And so you just leave it under the square root. And the one you can actually take the square root of, you write that number in front.
Okay. So we're basically trying to find x by using the square root method.
Right.
In order to do that, you got x by itself. You're trying to get x by itself. And in order to do that, you have to square root x squared and square root the 8, right?
Uh-huh. And when you
Got
square root a regular number, you have to put plus or minus in front of it. So don't forget that part, because you'll only get one of them.
Yeah, I didn't know that. Okay. When you square root a regular number, let me write that down. Yeah, because that makes sense because it could be two negative numbers
Right.
in front of it. Okay.
Okay, now I'm going to do one that's a little bit more complicated, okay?
Okay. I'm ready.
All right, so I guess I should go back to your thing that you gave me. Hold on. All right, so I'm going to do 28.
So was the answer to that one just x equals 2 square root of 2? The
Plus or
previous one?
minus 2 square root of 2.
Okay.
Those would be the zeros.
Okay.
First step is exactly the same. I'm going to make g of x 0. Then I'm going to move the 1 over to the other side. Now I'm going to take the square root of both sides. What's the square root of 1?
1. Mm-hmm.
So this stays plus or minus 1. And then because I took the square root, the square cancels the square root. So this is just x plus 2 here.
Yes.
Now I'm going to bring the 2 over to the other side, so I get x is equal to negative 2 plus or minus 1. I'm going to separate the 2. So I have minus 2 minus 1, and then I have minus 2 plus 1. What's minus 2 minus 1?
Negative 3.
What's minus 2 plus 1?
1. Negative 1.
So those would be my two roots.
Not bad.
Any questions about that?
That's pretty straightforward.
Mm-hmm.
So we did complete the square root method and factoring. And then we also did the quadratic formula too.
Am I going to a different page now?
I just wanted to see if there was anything on that one page
Okay.
that we find the real zeros of each function. What are the x-intercepts of the graph of the function? Is that just saying do whatever you want to do? 57.
What section is that? Tell me the numbers.
57 through 74.
Find the result function. What are the x-intercepts of the function? So the real zeros and the x-intercepts are the exact same thing.
Okay.
It's is just two different ways of saying the exact same thing. Like, these are the zeros for the function, right? These are also
Yes.
the x-intercepts for the function.
Mm-hmm.
So they're saying the exact same thing. It's just the same word saying the exact same thing. And I guess you could use any method you wanted to use in order to find them.
Okay.
Okay, I want to do, just so you have this to go back and study, I want to do question number 66. Do you see that one?
Yes. I see it. So we're gonna do 66.
Yep.
Okay. Okay, I'm ready. 30x equals 2x plus 5 squared minus 2x plus 5 minus 6. Okay.
Okay, I'm going to teach you a method that your teacher probably didn't teach you.
Okay.
But it's going to make this question a whole lot easier. So the first thing I'm going to do is I'm going to substitute in for this. So I'm going to say that a is equal to 2x plus 5. Look at how the equation changes. So this is a squared minus a minus 6. Do you see how I got
Yes,
that?
I do.
Now I'm going to factor this. This is really easy to factor. I need two numbers that multiply together that give me negative 6 and that add together to give me negative 1. What are my two numbers?
2 and 3. It's gonna be -3 and 2.
Can I tell you something?
Hmm?
The bigger number always has the same sign as the middle term. I don't know if you know that or not.
Let me write that down. That's what I was thinking of in my head, but I like that you had said it. So let me write that. The bigger number always decides the sign of the middle.
Of the middle term, yep. Okay, so now that I have this, right, I'm going to say that this is a minus 3 and a plus 2. And that's equal to 0.
Okay.
Now I'm going to take this and I'm going to substitute it in for a in both places.
Mm-hmm.
So I'll draw an arrow in a different color. So I'm going to take this thing and I'm going to substitute it in for a there and there. So now I have 2x plus 5 minus 3. And then this is 2x plus 5 plus 2. Do you see what I
Okay.
did there?
Yes.
So this is going to change. This is 2x plus 2 equals
Mm-hmm.
0. And then this is 2x plus 7 equals 0. Now I'm going to solve for x. So I get x is equal to negative 1 there. And then I get x is equal to negative 7 over 2 there. So those are my two intercepts, or zeros, either way, whichever way you want to label it.
Minus 7 minus 7 divided by 2. X equals 7 or negative 7 over 2. Okay, cool.
So if you have something that looks really, really complicated, try to find a way to simplify it by changing it all to one variable. Because this is much easier to do than that.
That's cool. I never would have thought of that.
Okay.
And are we allowed breaks in the session?
If you want to take a break, you can. How long of a break do you need?
Just like 5 minutes.
Yeah, sure. I can give you 5.
Okay.
I'm just like at 11:45. I don't know how much energy I'm gonna have for you because I've been up since like 6 this morning. So.
Okay.
So let me pause your video.